evening, everyone. I'm delighted to be here. Privilege and honor to speak with all of you. I'll just correct the topic. It's general intelligence, not jungle intelligence. So we have an intriguing topic today. It's about future of generative AI. See, researchers call out the distinct possibility of what is called artificial general intelligence, or AGI, which is general purpose intelligence or super intelligence. And researchers say that in the very near future, and the keyword is very near future, AI can get smarter than human beings. And then, as we all know, the more smart controls the less smart. So in the next few minutes, we will cover a little of what the future holds in store for us. But before that, a little bit of context setting. See, AI is India's opportunity to leapfrog because it democratizes access to technology. And Niti Aayog says that if India sustains a GDP of 10% continuously till 2047, the Amrit Kal, the 25 years, then we become a $32 trillion economy. But if we continue to grow only at 6%, we just become a $12 trillion economy. So to bridge this gap, we need to pole vault technologically in sunrise areas, not in the traditional areas alone, but also areas like generative AI and IoT and cloud and blockchain. Now, there are some stunning numbers here. The time to reach 100 million users. If you look at something like Facebook or LinkedIn, they've taken 4 years to 5 years to get to 100 million users. Well, ChatGPT took just 2 months to get to that 100 million mark. There are other telling data points. For example, 92% of Fortune 500 companies, they already use generative AI in production, right? So these are very telling statistic. This is somehow not working. If you can just go on to the next chart. Yeah. Yeah, not working. Change to the next chart, please. Yeah. So just a little bit of background. Yeah. So there are two paradigms of intelligence. One is modeling the mind, and other is modeling the brain. So when I was doing my bachelor's in computer science in the 1990s, most of what we were taught were about modeling the mind, reasoning, representing knowledge, and so forth. But more lately, it is about modeling the brain. So if, for example, if you want to detect, identify, learn to identify an airplane, you first learn to detect the edges, the lines, the edges, and then a combination of edges. It could be the nose of the plane, it could be the wing of the plane, and then you have a neural network layer, right? And then you try to detect circles, and if the circle is near a combined edge, it could be the wheel next to the wing, or it could be the cockpit near the nose of the plane and such. And then you add layers, right? And then you have weights and gradients, and then you fine-tune that weights, and that's the concept of neural networks, or deep learning. Now, what that has transformed to is, it is the concept of foundational models and large language models. So for a very long time in cognitive science, what was believed was that if neural networks can be trained on a vast amount of data, they can do very complex things. But human beings, they don't need to be trained on such vast amount of data. So if for example, if there is a new helicopter that has come in, to recognize that new helicopter, a human being need to be shown only 10 pictures or 20 pictures, while a neural network has to be literally trained in hundreds or thousands of images. So the humans had an advantage, was the opinion. But people don't talk about this advantage anymore, because with the advent of foundational models, the equation has changed. Now the question is, given a foundational model that is pre-trained in mammoth amount of data, the P in GPT stands for pre-trained, the question is, how much additional training is needed to do a new task? Yeah? And the answer is not that much. So human beings gradually lose the advantage that they had. And now what is the concept of an LLM? And an LLM extracts all of digitized human knowledge into a neural network. So you have the entire internet in a supercomputer, except that the data is not accessed, it is as part of trained neurons. So you may need a big GPU to run the LLM, but understand that the LLM is equivalent to vast amounts of, all of human knowledge digitized, and then a reasoning engine and a cognitive engine unleashed on top of it. So that's the summary of the present. Now the future of what's called artificial general intelligence, general purpose intelligence, right? So see, humans, AI, unlike humans, is extremely good at one thing. It's in transferring intelligence and preserving intelligence. Preserving intelligence we understand because human beings live only for 3 billion seconds, and which is 90 years, and after 1 billion seconds, cognitive decline sets in. But this is not applicable for AI, and the important thing is transferring intelligence. Assume that there are 1,000 people all reading different books, 1,000 different books, or learning 1,000 different courses. So now, can they perfectly transfer what they have learned? The answer is not really. But in the case of AI and large language models, they can do this. So each model, let's assume you have 1,000 models trained on different data. They're all represented as billions or trillions of weights or gradients. It's only a question of copying over those weights to get a perfect knowledge transfer. So with this, huge advantage in preserving as well as transferring intelligence, AGI seems real, right? So the benefit of doubt should go to the researchers that say that just in a few years, around the corner, 2 to 5 years, we will see the concept of super intelligence, super smart AI. Now let's see, already there are indications that we are reaching general purpose intelligence because the vanilla GPT-4 is able to pass law exams in the 90th percentile without having domain-specific training. So we are already in that path. And things like agentic AI. What's agentic AI? So they are pieces of software that can see and hear and read and then take actions, decision-making initiative based on what they've seen and heard and learned, and to realize tangible business benefit. So today, most applications have complex agentic workflows. Now we look at, with artificial general intelligence, what are the novel threat vectors that will get opened up? It is going to unleash huge amount of creativity gains and improvements, but then what are the new novel threat vectors that we will need to grapple with? One is responsible AI. Yeah? We are already grappling with some of this, but this is going to become more crucial. Responsible AI, the first question is, if there is a bad result, who's responsible? So usually there is a deployer of AI, there is the maker of the generative AI application, and then there is the AI maker, and then the LLM maker. So then each party in this chain, they cannot offload their ethical and legal and professional responsibilities downstream with just a liability statement. So recently there was a news item where Air Canada's bought threw up a discount that did not exist, and the passengers sued the company, and the court ruled that the airline was responsible for the discount that did not exist, even though because their a generative AI app spit out that information. So this is a hard problem. Another hard problem to solve is the problem of bias. So we know that LLMs are trained on the internet, right? They suck in the entire internet, vast amount of data. And now the internet also has bias, built-in bias, existing real biases, historical biases. So all of that also gets sucked into these models. And it is not easy to remove this bias. So if you want to remove a segment of data from a data store, it is easy. But you can't cut or scissor away the neurons, just those neurons that embed bias in it. Right? So this is another hard problem that will get harder. There are techniques, there are technological breakthroughs that are happening to handle many of this. But these are hard problems nevertheless. Similarly, copyright. Because all the LLMs absorb the entire internet, they also absorb copyrighted material. They also absorb your public profiles. Now, regulation may give you the right, like GDPR, for example, to ask a deployer of your public profile to remove that or reverse that. But with an LLM, you can't do that because, like I said, you can't really snip out the neurons that hold your public profile. It's ingested deeply. Now, so these are very complex legal problems that would be very intriguing in the near future, especially with artificial general intelligence. Now, what about AI-generated content? See, today, LLMs are primarily trained on human-generated content. and they generate what is called AI-generated content. Now, it follows that the LLMs of the near future will be trained by a combination of human-generated content and AI-generated content, right? And over time, the AI-generated content is going to overwhelm or outnumber the human-generated content. It's just only a question of when, yeah? And then the models would be trained with more and more of AI-generated content. And currently, tests say that 5 iterations down the line, models collapse with existing technology. And there are societal implications also with more and more AI-generated content. With the advent of fakes and such, you, as a society, tend to start viewing things out there with skepticism, right? And fakes can impact even democratic processes. So these problems also will get harder as we move on to AGI. And similarly, problems like model poisoning, hallucination, the models themselves are probabilistic and indeterministic in nature. So the two of the main solutions, one is legislation, right? Government legislation. An example of legislation could be a percentage of your computational resources as an AI, for an AI maker, has to be devoted to safety testing. Say, for example, 25% only devoted to the safety testing and the rest for development testing. Or legislation that calls for attribution. So unlike a web internet search, a chatbot answer is not going to give you attribution because it's complex and it is built deep inside the neural network, right? It doesn't work that way. So can legislate mandate, some of this. So I conclude now by just talking about the hardware aspect, the world's AI infrastructure, because there are problems. Some of these GPUs are more expensive than luxury cars today, and the power consumption is, one GPU consumes as much power as an average household. So see, the future is going to be really strange. It's going to be intriguing and interesting. The problem space will be multidisciplinary. On the one hand, it is going to span problems of GPU performance and cooling and cost. Then it is going to into making LLMs larger, also making LLMs smaller, right? Miniaturization, and also problems that we discussed like responsible AI, debiasing, deep fakes, and so on and so forth. So with that, I stop. Thank you all.